Hi guys, so in this video we're going to look at implicit differentiation. So up to now we've learned all the rules, the quotient rule, product rule, chain rule. We've learned how to differentiate trig terms, inverse trig terms, parametric terms. But all these values, all these differentiations, we were given y in terms of a function of x. So i.e. y is something x, y is cos x, y is sin x, y is x squared, and so on and so on. However, sometimes the equation itself might not be y in terms of x. For example, let's say x squared plus 3y squared plus 2xy is equal to sine y. So as you can see, it's not y in terms of x. So what we would ideally want to do is change it into, or rearrange and make y the subject, right? However, for this kind of case, it's kind of difficult to do that. And so what we can do instead is differentiate it implicitly. This just means we differentiate it straight away rather than having to rearrange for y. So you can see here how we would differentiate implicitly. What this means is any function of y, you differentiate as you would normally do with x, and then you times it by dy by dx behind it. Okay, so that's very, very important. Whenever you differentiate the y, you times dy by dx behind it. So if I was to give you this example here, well, we can even try this one here. Okay, so as you can see, I will differentiate each term on its own. So x squared, the derivative of x squared is 2x. Now, 3y squared, just imagine you just differentiate that, it's just 6y, right? So it's going to be plus 6y. But because I differentiated a y term, I have to times it by dy by dx behind it. And that's it, just do the same concept. Plus 2xy. As you can see, this is a bit more difficult, but you can see it's two functions multiplied together. We have a 2x and a y functions multiplied together, meaning that we can actually use the product rule, which we've learned earlier. So let's label u as 2x, v as y. So the derivative of 2x is just 2, differentiating y, just think about it as differentiating 1, but because I differentiated y, I have to place a dy by dx behind it. So using the product rule, I multiply them together, so I get 2x dy by dx plus 2y, because I cross multiplied like this, right? And that's equal to the derivative of sine y. So just how would you differentiate sine? Well, that gives me cos, right? So it's going to be cos. The angle in this case is y. And once again, because I differentiate the y term, I have to times it by dy by dx behind it. It's just as simple as that. Just use the same rules we've learned for differentiating x terms, but for y, just place a dy by dx behind it. And from here, I can go even further and just rearrange for dy by dx now, right? So I can say, bringing all the dy by dx terms to one side and factorizing. So I have this 6y plus 2x. I can bring this cos y to the left-hand side as well. So you get negative cos y, close bracket. And bring the other terms to the right-hand side, so minus 2x minus 2y. And then I can divide it to leave me with my dy by dx only. Like this. So as you can see, even though we don't have y in terms of x, we can still differentiate it. And this is called implicit differentiation. Right, let's take a look at some more examples. So let's say I have y is equal to, no, sorry, not y is equal to, let's go for x minus y to the power of 10 plus 2x is equal to tan 4y. Okay, so obviously it's hard to get y in terms of x, but I can differentiate it implicitly. So x minus y to the power of 10. We know when we see a power, chain rule, right? So as I said, the chain rule, so we got 10 comes down first. I differentiate the inside of the bracket, meaning I get differentiating x is y minus differentiating to y is dy by dx. Then I rewrite the whole bracket out, so x minus y minus to the power of 9 now, plus derivative of 2x is just 2, and that's equal to differentiating tan 4y, we get 4 sec squared 4y, but remember I differentiated the y term, so I have to times it by dy by dx at the end. And I can rearrange this to get my dy by dx on its own. Okay, so as long as you just follow the rules and put dy by dx behind the y, then you can differentiate all equations. Let's take a look at another example. So let's say we have 2 sine 5y over x plus, let's say, ln x times y is equal to 5. So the first term here, 2 sine 5y over x, is a function over a function, so quotient rule. So our u is going to be 2 sine 5y. Our v is going to be x. So therefore, u prime is going to be 10 cos 5y, but because it's y, dy by dx behind it. And our v prime is just going to be y, 1. So we're going to have v times u prime, so it's going to be 10x cos 5y dy by dx minus u times v prime, so 2 sine 5y, all over v squared, so it's x squared, like this. So even though it's a bit long, the quotient rule still applies, right? Right, ln xy, so we know ln terms is always going to be a fraction when we differentiate with x times y on the denominator. We now have to differentiate xy, so there's two functions multiplied together, so we just have to use the product rule. U being x, v being y, u prime is 1, v prime is dy by dx. So therefore, we're going to get x dy by dx plus y is equal to the derivative of 5 is just 0. Okay, so you can see a combination of the quotient rule and the product rule being used. Let's just try one final question. So let's say we have sine squared 5y plus 2x e to the 4y is equal to, let's go for sec 4x. Okay, so first things first, sine squared 5y is sine 5y raised to the power of 2, so we know chain rule. So the 2 comes down, I differentiate my sine 5y, which will give me 5 cos 5y. But because I differentiate the y term, place dy by dx behind that. And then I put sine 5y, because we minus 1 to the power, plus 2x e to the 4y. Once again, two functions multiplied together. So the product rule, so I'm going to say u is my 2x, v is my e to the 4y. Differentiating 2x is just 2. Differentiating e to the 4y is 4 e to the 4y dy by dx. And so it's u times v prime. So it's 8x e to the 4y dy by dx plus v times u prime, which is 2e to the 4y. And that's equal to sec 4x. So sec 4x is simple. We just put 4 sec 4x tan 4x like this. So as you can see, all the rules apply as long as you know which rule to use and you're using it correctly, and you're remembering the dy by dx after any derivative of any y function, then you can just about differentiate any equation that you are given.